Hi there, welcome everybody. Allow everybody just to take their seats. For those who don't know me, my name is Adrian Cole. I'm your building host here. So this is our Digital Aviation Research and Technology Centre, DARTEC. And I'm here to welcome you to Cranfield and most particularly welcome to this wonderful facility that's opened just less than a year ago. So I'm hoping that you'll have a wonderful day here with us. It's going to be a hot one, so please just take water and fluids and look after yourself on that front. And enjoy the many, many presentations that have been prepared for you. It's my job to just take you through some housekeeping. Most particularly the fire evacuation procedures. We're not expecting any practice alarms or any particular events, but if the alarms do go off, they are for real, in which case what I'd like to ask you to do is to make your way down the circular stairs or through the back stairs here or through the stairs at the far corner, and make your way out of the building, and the fire assembly point is literally just the other side of the small road near the main entrance. So please do make your way over there if the alarms go off. Also, the conveniences, toilets, just there. You don't need to go downstairs, but if you feel that there's an incident arising, myself and my colleagues are circulating around the building. Just come and find us, and I'm sure we can help you out. With that, I'm going to pass you over to your host for the day and wish you a very successful meeting. Thank you indeed.
Thanks, Adrian, and the DARTEC team for hosting us. Good morning. Welcome, everyone, to the Airspace of the Future Showcase event. Thank you to everyone who's joined us here as DARTEC, but also to everyone who's virtually attending. My name is Krithika Ramesh. I'm a Senior Project Manager at Connected Places Catapult and the lead PM on the Airspace of the Future project. The contents of today's showcase have been carefully curated by the 9 partners who've been working collaboratively on the Airspace of the Future project over the last 17 months. We hope that the learnings we share today contribute positively towards creating an airspace that is safe, sustainable, and accessible to all. Today's event is going to run from 10:30 to 1 o'clock, with the opportunity for networking till 2:30 for those attending in person. We encourage you to be curious and ask us questions, but if we could just wait till the 12:30 Q&A session to discuss these, that would be great. Those attending online, feel free to ask questions as we progress through the presentations. Use the Q&A section, and we'll pick them all up together at 12:30. That's it from me. I'm going to introduce Paul Bate from Connected Places Catapult to introduce the project now. Thanks.
Cheers, Krithika, and thank you, and welcome to everyone who's online today. So I'm just going to give you a very quick overview just to introduce and set the scene for what we're doing here on Airspace of the Future. And the key question is well, why are we doing this project? Why are we interested in this space? And the answer is actually the market opportunity. Drones are a new technology, and there's certainly, in terms of what we've looked at and what we're seeing in the marketplace, there's lots of opportunities for there to generate opportunities in terms of new jobs, new businesses, new ways of doing jobs more efficiently and more effectively. PricewaterhouseCoopers did a report a number of years ago which estimated that by 2030 drones could increase UK GDP by £42 billion and potentially another 628,000 people working in the drones economy. That's 76,000 drones potentially operating in the UK skies, and across various sectors. For construction and manufacturing, there's opportunities worth uplifting GVA by 8.6 billion, or across the public sector by 11.4 billion, or the wholesale and retail trade by 7.7 billion. Big numbers, big opportunity. And there's more recent reports come out more recently as well. For example, Morgan Stanley have just recently brought out some research which says that the global market for this could be worth something in the order of $1 trillion by 2040. So there's a big market opportunity here, which means for the companies and the country as a whole, this is something that we want to get involved in, we want to support, and we want to enable going forward. With that in mind, the government launched the Future Flight Challenge a number of years ago, which is covers both the drones and the air traffic management systems and other types of electric aviation. The government's investing £125 million in this area through the Future Flight Challenge, and this is supporting the development of greener ways to fly, all electric aircraft deliveries by drones, etc. And that's being matched by £175 million from industry. This project is part of the Future Flight Programme, and key things which we're looking at part of that programme is to creating the aviation system of the future, increasing mobility, improving connectivity, advancing electric and autonomous flight technologies, helping UK to meet our net zero targets, and also driving UK investment in related manufacturing and service opportunities. So there's definitely, from the UK point of view, from the government point of view, that commercial imperative to support innovation and investment in this area. So this project, has been worked by bringing together people across UK industry, academia, and the Catapult network, and is looking at that vision for a viable future for the airspace and airspace management. We've been looking at use cases to understand the opportunity, and also then the technical and regulatory requirements that are needed to support it. We've been looking at the technological components required, and also how to integrate all that into an airspace management system. Taking a view on the rules and regulations that's also going to be required to enable this system to come forward. So what we can see is that what we've done is in this project is we've seen there's a big market opportunity. The government has recognised that and is investing in innovation in this space. This project's part of this programme, and we've been looking at a certain part of that, particularly around that future airspace and future airspace management. And how we can bring that to work, and how that works both from a technological and a system and a regulatory requirement. I'm now going to hand over to Phil Vernal from Thales, who's going to talk more in detail about the project, what we've done, and give us more of a detailed introduction. So thank you, everybody. Welcome, and I hope you enjoy the rest of the presentations we got today. Thank you.
Thank you, Paul. Well, where to start? It's always a difficult thing when you're looking at a program as to what is it you're going to do? What are the key things? Paul's given us an outline of why, but the what. So we felt we needed some sort of vision statement of where we wanted to go, and you always end up with one of these kind of long sentences that looks like it's been designed by a committee, which we have here. I'm going to take you through it because I think there's some important points that we were trying to push forward and why we wanted to do this. So, routine operational drone services in a safely coordinated environment on a regional and national basis. Well, that's what Paul has talked about, making sure that the systems are safe, they're coordinated, and they deliver what needs to be delivered, as Paul's just outlined. A valid and robust business cases. So again, making sure that this makes economic sense. How are we going to do it? Well, we're going to do it through looking at synthetic environments. So synthetic environments to help us deliver an understanding of what these elements are going to look like. Stakeholder and public engagement, end users, regulator, the public at large as well, underpinned by an integrated transport model. So the system needs to be part of a larger piece. Drones aren't going to operate in isolation. With aviation at its core and exploitation roadmap for the UK. So with aviation, it needs to be at the centre of this. Again, as Paul said, electric aircraft, much wider piece rather than just drones. And where are we going to go next? Because we're trying to push this forward to a 2030 timeframe. We don't see this happening tomorrow. Next year, it's going to be at the end of this decade, because there's certain technological advances that need to be put in place before we can get there. So a long sentence, hopefully it makes sense. Hopefully that's helped you understand what's in there and taken the time to run through it. So putting that into a bit of a contextual picture, we've got on the ground, we've got rural areas, we've got critical infrastructure, urban areas, there's a whole lot of other infrastructure on the ground, and then we've got in the air, we've got piloted aviation, we've got drones, satellite systems, and the important parts are the red arrows and the black arrows that join all these elements, which show the connectivity. The one thing that's going to be one of the key enablers to drone operations is this connectivity, the ability for everything to know where everything else is and what everything else is doing. Otherwise, you're going to end up with some severe issues and challenges in the way systems integrate. And obviously, it has to be controlled. So, looking at what we were doing, on the left-hand side, you can see today's airspace. It's complex. There's different types of airspace. You can see different classes of airspace, lower, middle, upper airspace. Eventually, many years from now, drones will operate in all of these zones, all of these flight levels. We're looking for this project at the sub 500 foot. There are reasons for that, primarily because manned aviation, obviously apart from taking off and landing, is not supposed to operate in this sub 500 foot layer, by and large. So looking at that and then expanding that piece out on the right-hand side of this diagram, you can see that we've got three different types of airspace, X, Y, and Z. Now, we didn't dream this up ourselves. We pulled upon information that had already been generated through an organization called Chorus. And you'll hear a lot spoken of Chorus. It's a European analysis that looked at the way drones can operate. It developed a use-based concept of operations. And it's been looked at, so they've looked at type X airspace, which is basically fields, basically where there isn't anything much. Higher risk, which might be critical infrastructure, as you can see there, some power lines and some power plants. And then the most complex, which is the type Z, which is built up, highly populated urban areas. And then you're probably thinking, well, what's U1, U2, U3, and U4? Well, the Chorus concept said, well, we're not going to go straight into being able to operate fully in type Z airspace. We need to grow the capability. Systems are already pretty much at U1, which I won't go into the complete definition of what that is, but it's a fairly basic operational capability for the drone and the systems that manage drone flight. And then into U2, U3, and eventually U4, where you've got U4 is an all singing, all dancing, fully automated, autonomous, potentially completely automated system, where manned operation within the system is minimized to maximize the efficiency of the system itself. So we're certainly looking at moving into the U3 area, and that's the area of research that we pushed ourselves to. We didn't go as far as U4 because that is highly complex in the way that the systems would work. So you'll hear a lot about type X, Y, and Z airspace. You'll hear a lot about Chorus. Hopefully that's explained what these terms mean. So looking at the airspace of tomorrow, we can have drones flying. So, and we need to look at, it's not just the drone part, so we can look at the use cases, we can look at where drones are going to operate, what they're going to do, the airspace they're going to be flying in, and making sure that the operations are safe, and the benefits thereof. But the point is that you've also got to look at the management infrastructure that sits on the ground and enables their operation. And that's the computing systems, which may be cloud-based, which you can see represented on the left at the bottom there, but also the communications infrastructure down on the bottom right, which may be part of the mobile telecommunications systems, may be radar, may be satellite to manage the drone systems. So as I've said, knowing where everything is and what everything is doing is important. And these two worlds need to operate in harmony. So once we've got that, we can then look at operating on all the volumes across this diagram that I've shown you earlier with the different types of X, Y, and Z. This diagram is slightly more complex because it breaks down into ZU, which is urban, and ZA, which is airport. But the rest of that, you can see there's a lot of similarity between that and the previous diagram that you were shown. So, as I said, there's today's airspace. And we've got some challenges. What are we trying to do? Well, at the moment, we can operate under a visual line of sight. In other words, the operator needs to be able to see the platform and, more importantly, in some ways, see the airspace that is proximate to that platform, because the operator is making sure that that drone avoids all other airspace users. And he can only do that by having eyes on. So the challenge is to move beyond that into what is known as beyond visual line of sight, or BV loss. Again, a term you'll hear quite a lot today. And at the moment, that's challenging, and the route to get there is not clear. For this study, we've made the assumption that that has been solved. Broad assumption, but 8 years' time, hopefully we will have got there. At the moment, the way that missions are planned is manual, and it's intensive. There's a lot of manual work to be done. Eventually, that's all going to become automated. And at the moment, the amount of deconfliction for airspace is pretty minimal. Aviation, manned aviation, does this because there's a person in the cockpit who can look out of the window. In uncontrolled airspace, Class G, and in controlled airspace, there is a controller who's managing that. So obviously in a drone, there's nobody there who can look out of the window, so deconfliction is key. There's no uniform along. We didn't really understand what the business models look like. So one of the products for this, as you'll see later, is a lot of information about business model and business modeling. So, well, you've already heard that there's 9 organizations involved in this program. This is what they are, and the type of things that they bring: regulatory compliance knowledge, UAV traffic management systems, real-time simulation, business analysis, enterprise architecture. You'll see a lot of information today across all of these, and there's a lot more. This is just the top 10 of the types of systems and the types of knowledge that the team has brought. I'm not going to say that there hasn't been times when it hasn't been challenging, but then challenging is good in a lot of ways. We've worked together, we've rubbed along, we've been going for 15 months now, I think it is, and nobody's picked up their toys and walked away, so we must be doing something right. So what are we going to see today? We've just given you a brief on the left there of the study aims. When we did the study, we've broken it down into a number of blocks flowing through in a kind of a waterfall process, as you can see in this picture. We've looked at use cases, safety and airworthiness, quite a lot of work on the architecture, looked at the market. At the moment, we're running through trials and we're going to do the analysis following that. And then we're beginning to look at the future roadmap. So the work on the future roadmap is very new. And the person that's going to present that is literally kind of probably doing the work now in order to be able to present it later today. So that's how we've broken the day up. In a moment, I'm going to pass over to Alberto to run through the use cases. So after this opening, you're going to see 6 further briefs and then a summary and a questions period. So I shall hand over to Alberto.
Very much, Phil. Hello, everyone. My name is Alberto Martin. I'm a senior transport modeler at Connected Places Catapult, and I'll be talking to you about the use cases today. I'm going to start explaining why there's like a use cases work, part of this project, and the main reason is to find good examples that have expected high value in 2030. And the high value is not just economic, but is also environmental and social one. And this would be good examples to justify the need to develop a UTM enterprise. As part of this process, we've developed a high-level assessment framework to assess the use cases in different dimensions: economic, environmental, social, operational. Through the process, we found as well identified some opportunities, risks, barriers, and enablers. And we've as well developed a tool to estimate airspace usage by application, because these numbers were useful and required by our partners to pass them through the architectural model, digital twin, and trials, as well as the market assessment. And with this information, they will be able to assess, like, if the UTM currently will have the capabilities to cope with these volumes and where are the bottlenecks, etc. Also, one of our aims was to collect stakeholder information, external, as well collect the internal expertise from the partner to validate our assumptions. In terms of the workflow and use case development, we went through 3 main phases. The first phase was more exploration. So we've done an extensive background research where we explored the national and international a current use of drones and potential use of drones. And we end up developing a big database with 129 use cases. And we've as well enriched our findings with stakeholder engagement interviews, with workshops with the partners to get more information. The next phase was a refinement phase, so that's where we developed some criteria to, and also the categories that are relevant for the use cases, to categorize them and also help eliminate the ones that we're not interested in and prioritize the ones that we wanted. And with that, we've done some clustering exercise and we managed to bring to a short list. And in the final phase is more like a exploitation and testing phase. So we trimmed down this long database into like a top 11 use cases and went down to a top 3 that these were analyzed further into the market assessment. Here we just show some of the documents, of the main documents that we base our work on. UKRI, previous work, Connected Place Catapult, CESAR, PwC. So we've as well been documenting all of that. In terms of the activities developed, in defining, exploring the use cases, defining them, and then shortlisting them, we've done some stakeholder engagement. We've done this through interviews, but also workshops. And because we were like in the lockdowns, etc., many times we had to do them online, but turned out to be quite useful using some like online platforms to combine our ideas with post-its, with like where we had really rich conversations to gather all our thoughts and convey on the results. We as well collected some of the drone challenges. As well, we've collected failure cases, and we've identified which use cases would be more prone to certain failure cases, which we thought was useful. And then we as well done an exercise of horizon scanning, so understanding what is current, what is future, what is going to be the blockers or like the technology, etc. And we've been documenting and referencing the materials. So right, we had this big database, so we first started including categories to classify them and to be able to work better with them and do the analysis. So this exercise helped us to map them, and on the first graph, it's very small, but on the x-axis you see which is the responsibility class, so going from VLOS, visual line of sight, to VBLOS. And then on the vertical axis, that would be the operational risk classification, so going from open to specific to certified. So basically, the more towards the top right corner, the most complex space would be looking for the use cases. So this was very useful because we wanted to capture like all the complexities, to give that information to the partners and then be able to combine them and create interesting like situations, the confliction, etc. And by also putting them together, we identify some clusters, and that's what you see on the right side. And we, because of their nature, so basically these use cases operate very similarly. So in terms of the digital twin, the architectural model, they would be equivalent. But so for us, it's just to show that there's, in some of the clusters, a lot of examples. We had to apply some filters to be able to trim down, and some of them are, for example, the expected high industry cost savings, as well the ones that we expected to be like maturing off in 2030. So we wanted to target those, and then we excluded things like, for example, being likely to be operating in VLOS and open airspace, because those wouldn't challenge the current limitations. So we came first to a top 11. We wanted a top 10, but we split it in two. So these are the different clusters, as you can see there. The sizes of the stars that kind of show the amount of examples. So environmental conservation, agriculture, we found quite a lot. And at this point, we gave a description, a quite good description of how each of these would play. So I won't go into detail in all of them. For example, heavy goods transport, we pick one example of a warehouse situated like quite close to an airport, but they needed like a quick delivery of a spare part of a plane, and because time is of the essence, you could send a heavy drone transporting that piece. Then we pick as well some things related to like aircraft and airports, so doing the surveillance, the monitoring and coordination with the security team. And for example, telecommunications as well would be one use case where there's a catastrophic event, the signal is lost, so you send a drone to temporarily give signal to the people, to the rescue team. In this slide, we just show that in assessment criteria, so going from this top 11 to top 3, we have to give a better and more rich picture to the rest of the consortium to make a decision on which use cases we're going to go for to understand with more detail. So these are the dimensions: operational, economic impact, environment, and social impact. And for each of them, we define sub-criteria with a definition, and then as well a definition of what we consider is low impact and high impact. So, for example, in operational, were things like the amount of infrastructure requirements, if it's more intensive or less intensive. In the economic impact, the amount of cost associated with running the service, not just the drone, but infrastructure, the training needed, etc. Then for the environment, key things like the noise and the noise in the context, so understanding like, okay, it's going to be noisy, but it's already in a quite noisy environment, as a different perception as if it's like just in the middle of the countryside. So taking all that into consideration, and then social impact, so public acceptance, data privacy. If it's flying over the houses, people would be a bit more like not happy with that. And then like human interaction. So we kind of came to these three. We agree because each of them is unique in a way, and they all have value in different sections, but they kind of give a good picture. The first is about inspections. Inspections, there's many things, infrastructure, but we kind of focus on the linear inspections, so power lines, rail tracks, roads, etc. This one would give a lot of benefits in terms of cost savings compared to the business as usual. And also, very important, would remove people from dangerous situations. So that's a really interesting one. And even though there's currently some in operation, just like breaking some of the barriers, that will amplify the benefits. Then we have light goods transport, and this is transport that are below or equal to 3 kilos. We're looking at groceries, standard parcels, takeaways, these kind of things. This is the one we thought with more commercial impact and potential, and we expect as well like high volumes for this. And finally, blue light services, we focused on the police application, and within the police, we identify as well, like there's some events that are scheduled, like sports events, and some others that are more like short notifications, so you need to send for crime, etc. So this one specific would add a lot of like social value and value for society to improve the current capabilities of police. So in terms of outcomes, we came up with an extensive database of more than 100 potential use cases, and as well some key fields that we used to categorize them and to identify the operational complexity, as well with like some economic impact and others that allow us to classify and operate with them. The good thing is that it can be revisited, can be expanded, and gives a kind of like a framework, a structure to do that for the future, because more will surely come up. We've established a methodology to do a shortlisting procedure. We've done this in collaboration with the consortium, getting all the feedback, and then we've done jointly as well a multi-dimension assessment that I showed before, and how that helped us to kind of decide on which three. Throughout the process, we've as well done stakeholder engagement interviews and consortium workshops, and we collected all the feedback to validate assumptions. We developed this tool to give some estimates of expected amount of drones and volume of drone flights in 2030 by application, and this will be passed to the other partners to do further work. And finally, yeah, this use as well, apart from the volumes, the use cases characteristics, those were as well passed on and informed. So now I'm gonna give the floor to my colleague Phil Moorcroft, which is a business modeling and market appraisal team lead at Connected Places Catapult, and he's gonna run through the market assessment.
Brilliant. Thanks, Alberto, and good morning, everybody. So as Alberto mentioned, I'm the team lead for business modelling and market appraisal at Connected Places Catapult. And what I'm going to talk to you today is around some of the findings from the market assessment we did about the 3 key use cases that Alberto's just aligned to at the end of his presentation. So as Phil V mentioned earlier, there are obviously 2 sides to this coin. There's the drone operators and there's the airspace management and all the infrastructure around it. Really, what I'm going to talk to you about this morning, and our focus at this stage was really around from the drone operators. So we had to put on their hat and look through their eyes to really try and identify what some of the key drivers are for the use of drones, and actually, is that going to be long term, or are we talking about a fad? You know, are there kind of sustainable and robust demand there? Part of that was also to look at what is happening currently in some of these sectors, what is the current state of play, and try and understand some of the use case characteristics. Now, this was really important because we wanted to use those characteristics to inform some of the scenarios and some of the information for some of the trials and the other parts of the Airspace of the Future project. As you can imagine, there's a huge amount of information that we found, and this is going to be a very, very quick run through of what we came across. So I'm going to start with the blue lights use case, which eventually evolved into the police force. Because as you can imagine, you know, blue lights includes fire service, healthcare, etc. And there's a broad range of scenarios that we really needed to narrow down that scope. So what we wanted to do was focus on the police force. Now, as most of us are probably aware, the police force are already using drones in a lot of their day-to-day activities. And really, this has been driven by drones being a cost-effective way for them to increase air support coverage, rather than having helicopters based at different bases across the country. You're literally putting a drone in the back of a police car ready for the point. Now, it's not to say that drones are going to replace helicopters at any time soon, or replace the National Police Air Support Service. From our stakeholder engagement, it was very, very clear that they see drone usage as a complementary tool. And therefore, actually, their future vision is to see drones and helicopters often operating in the same airspace at the same time on the same operations. So when we talk about unmanned aviation and manned aviation and integrated airspace, that's really, really important in this use case as well. Through our stakeholder engagement and the desk research that we did, we came across 3 key scenarios where drones are being used more than others. These are for searching for missing people, at crime scene or traffic incident investigation, or for support with operational planning around events such as sporting events, marches, protests, that sort of thing. The key differentiator here across the 3 use cases, or 3 scenarios, is that for missing people and crime or traffic scene investigation, these are really unscheduled events. For when it comes to support planning, there's this scheduled activity, flight plans can be put in, everything can be arranged. But with missing person searches and crime or traffic investigation, we could be talking about deploying drones immediately, basically in any place at any time across any type of airspace. And therefore, in order to maintain the benefit of using drones, i.e. the fast response times, we need to make sure that the drone operators are able to access the airspace quickly. One of the other key things to note here as well is that as we move forward and technology develops and regulation develops, being able to kind of automate some of the drone operations will be really helpful to the police force. At the moment, they're required to have 2 people operating the drone. If you can free those 2 officers up, that means they can concentrate on other activities around the incident that they're dealing with. So ultimately, what we came across was that, there is real strong benefits to using the drones. The feedback from all the stakeholder interviews that we did, all the desk research that we did, was that the police force, NPAS, others see real benefit to this. This is not something that's going to go away. It's something that is going to grow more and more. But actually, compared to some of the other use cases that we've explored, it's going to be relatively low volumes, very low volumes of flights. But with the kind of urgent need and the emergency need to often deploy drones, we can consider this to be an airspace disruptor. Moving on to inspections, and in particular linear inspections. Now again, this is another use case where there are already things happening and the use of drones for inspections is growing all the time. Again, the key drivers here are really about an increased efficiency and cost savings to infrastructure managers and asset managers, and particularly when you're talking about the railway or wind turbine cell towers, that sort of thing, you are potentially removing personnel from dangerous locations, and for these kind of stakeholders, that's a key area. However, key to unlocking these benefits really is being able to use BVLOS and fly longer distances. Network Rail, back in October last year, ran their first BVLOS trial. They meant they were actually able to cover 25 kilometres in one flight rather than between 4 and 5, and that makes a big difference to them from an efficiency and a cost savings point of view. That trial actually also included operating again alongside a helicopter, so again it reiterates the point about having uncrewed and crewed vehicles operating in the same space. So the bulk of our use case research focused around rail, but clearly there are widespread opportunities along loads of different kind of infrastructure assets. However, certainly in the UK, we're not a huge country compared to the US or Germany or others, so we've not got a huge number of assets. So actually, overall, the volume of flights per year we expect to be relatively low, certainly in comparison to light goods delivery, which I'm going to come on to next. But actually, one of the key things to mention here, and is really important from a UTM and an airspace management perspective, is that you will be operating around critical infrastructure. So it's important to make sure that the airspace is carefully managed and all the drones are safe. Moving on to our final use case that we really went into depth on, and that is light goods delivery. And this is the one that actually at the moment isn't happening in the UK, although there are trials happening internationally. Now, over the last few years, particularly driven by COVID, we've seen a massive growth in the demand for same-day and rapid delivery of parcels, groceries, takeaways, that sort of thing. Huge growth in your likes of Amazon Prime, your Deliveroo's, your Gorillas. But what we have found through our research is there is a massive discrepancy between the standard of service received in suburban and rural areas compared to urban centres. And that is really where we see the key opportunities around light goods delivery, is being able to offer greater service to suburban and rural areas. McKinsey did a report probably 5 or 6 years ago now, but actually what they found was, from a cost point of view, drone services were actually very cost competitive against other modes when serving rural areas. They also said that actually with the speed of service, they were very well suited to serving rural communities. There are, again, even within the light goods delivery kind of use case envelope, a huge number of potential business cases and business models around that. In particular for the trials, we've actually focused on same-day or rapid parcel or delivery services and the emergency delivery of spare parts. We've also focused on a package size of up to 3 kilograms, because that forms the bulk of the deliveries that happen on a daily basis. Okay. Now, to make the light goods delivery business models work, there are massive kind of technical and kind of business model complexities, no least from the competition from other modes, and actual delivery mechanisms from actually getting the parcels to people. Automation is another key thing to making that business model work from the drone operator point of view. Being able to have one pilot pilot many drones, or have a fully autonomous service, strips a lot of cost out of that business model. But ultimately, being able to operate beyond visual line of sight is a prerequisite, and it will not work otherwise. And what this actually means is that the light goods delivery operators and the UTM solutions providers have a heavily interlinked business model. If the cost of accessing the airspace or cost of accessing the UTM is too high, then that really impacts the cost of delivery, which can force demand down for those delivery services. So really, those two kind of stakeholder groups really need to work together to kind of make these business models work. Ultimately, if we can make that work, then we believe that light goods delivery will potentially be the heaviest user of the airspace moving forward. Finally, to sum up, we've come across 3 very different use cases, all with very different drivers, be it social benefits from the police force, the cost of savings for infrastructure managers from linear inspections, and the real commercial opportunities from the light goods delivery side. What is clear is that police force and linear inspections is underway, it's happening, it's expected to grow, and the changes to regulation to enable things like automation and BVLOS can really help that grow further and maximise the benefits those stakeholders are seeing. For light goods deliveries, there are still complexities to be solved, particularly around enabling operation. What you'll also see is each of those use cases has key different safety challenges as well. Police forces, we're looking at airspace disruption. Light goods delivery, we're looking at huge volumes of drones operating in a relatively small area. And you'll find that safety is going to be a huge topic throughout this presentation today, which kind of leads me on nicely to being able to actually introduce Craig Wilson to the podium, who's the program manager for Altitude Angel, and he's going to talk about safety and regulation.
Thanks, Phil. Good morning, everybody. So, as I've already said, Craig Wilson, Altitude Angel. So I'm going to be talking to you about safety and regulation. Before I do, I stupidly said that I didn't want a lapel mic. Usually when I speak, I go strutting off around the stage. So if you see me twitching, I'm desperately trying not to, because I'd only forget to turn it on and off and make a faff. So I'm going to stay still. No, I'll do my best. I'm just warning you, in case you see me start wandering off. You'll have to remind me to come back, otherwise you won't hear me. We talked already about some of the use cases and how we've had to restrict the scope of what we're doing for the project. As you can imagine, it's such a huge topic. And next, we're going to move into some of the more technical stuff that we've done and look at some of the modelling and architecture. But clearly, safety, and as we move forward, is absolutely vital for this to work. And working with within the regulations, developing the regulations, so that we have all these fantastic ideas and we have a vision for the future, but if we can't legally perform it, then we're all kind of wasting our time. So working hand in hand with the regulator and making sure that we're moving forward in a meaningful way is clearly vital for what we're trying to achieve. So the way we approached this really was we had a work stream where we looked around the current environment we're operating in. We then looked at the vision, and we've touched on that a little bit, but we'll talk some more. We then sort of looked at, well, what are the gaps? How are we going to take ourselves on this journey from a regulations point of view? And then finally, what have we done about it as part of the project, really? So, just moving on to the existing environment, as I think we would all agree, the commercial aviation sector really ramped up after World War II. When all of a sudden this technology was available. And we've grown our standards and then national regulation as a result to enable us to have what is now, a very well developed manned aviation environment, all based, as we touched on right at the start, on this sort of see and avoid principle. We have, however, moved forward from that. We've now got instrument, obviously, flying capabilities. to enable us to operate in cloud, and we found ways around that with technology, and they've been adopted internationally now as well. So, we don't think anything of being sat on an A380 that makes an instrument approach and you just pop out at the bottom and land. We've grown in with that sort of capabilities, and we've ended up in a world where we have controlled airspace linking hubs around the airports, and we've now got mature rules on equipment, qualifications, airworthiness to operate in that environment. However, those standards and regulations weren't developed with the sort of capabilities that we're talking about at the moment in mind. So where are we trying to get to? So the 2030 vision that we touched on, Innovate UK have done a lot of work in this. We've spoken very much around the UAV element here, but there's a whole UAM piece with sky taxis and all that stuff. So we're talking about quite an exciting world. And we need to find a way to integrate the uncrewed or drone aircraft into that UK airspace alongside demand. So we're talking integration, not segregation. It's very much our view that we can't start just dividing everything up and you can have that bit over there, we'll have this. That's not going to work. We're not going to be able to scale these types of capabilities and work alongside the people that are already using the airspace in the manned side. It's got to work together, and that presents a number of challenges. Conspicuity being a major one, of course, and solving that see and avoid principle when you don't have a single aircraft with a single pilot, or two pilots even, looking out of the window to make sure they don't bump into somebody else. You've got to come up with the technology that enables you, whether that's onboard, offboard sensors, to fill that gap. Now, we haven't addressed that specifically in this project because, again, you're opening up a whole can of worms there, and we could have several projects just trying to solve that, and in fact there are. But obviously, it's a requirement to be able to embrace what we're talking about today. Automation as well is the other one. So we're very used to this single pilot, single aircraft, and Phil touched on it in his presentation. To automate and to scale this environment, it's just not practical to have one individual operating a single drone to deliver you shopping, or when we really look ahead, UAM capabilities and everything. It's got to be automatic, and dare I say it, autonomous at some point. And the technology's got to help us solve those barriers. So we need an infrastructure that allows crewed and uncrewed aircraft to take off and land in diverse locations. I don't know what that is. I'm hoping that's a good thing. I'm going to carry on anyway, just to support the use cases that we've been talking about. So how do we get there? The regulations have got to evolve. What we clearly can't do is throw them all in the bin and get rid, because we've got an existing infrastructure that we need to maintain while we move to this brave new world. So we need to re-examine the technology requirements. I mean, the traditional 2 VHF radios and a transponder so you can fly in airways is clearly not going to work when you start looking at where we're going. So we have to accommodate other technologies. We need to look at public perception around people's views of having these drones zipping all over the place. I think we've just about got used to having A380s flying at height over the top. We're all comfortable with that. How are we going to feel when we're seeing numerous small drones zipping around the place? People will have privacy concerns and all that kind of stuff, and we need to work with the public. There's a lot of work to be done there just to bring all that in. We need to analyse safety and redundancy. We've talked about see and be seen, that's see and avoid. So we need novel conspicuity solutions, and it needs to be a layered approach. We can't, aviation, we have layers. We don't rely on one system. We make sure we've got something else. Channels have multiple radar frequencies that they're using. They have backup systems. We need to provide the same. We can't just stick an ADS-B card into our drone, go flying and expect that to do the job. It's just not going to work. So we need to think about how we deliver that. How do we deal with non-compliant platforms that we weren't expecting to be there but suddenly tip up? The manned aviation, it happens all the time. We have to deal with it. And this is just something that needs to be thought about. So that kind of automatic and, I say, autonomous. So what do we do? So we sat down and we pulled together some of the expertise. We reached out to the gaps. We engaged with the regulator, and we looked at a number of different areas to see what is happening in the existing market. So we looked at the existing regulations. We looked at the existing communications. We reviewed what was in place. And then we looked at how we would have to move going forward. So at the moment, if we take the communications as a perfect example, if you're using radios, you've got somebody in the aircraft, they can transmit to the local ATC authority, that works absolutely fine. Drones, when they're being controlled from the ground, what do? Do you use cellular? But you've got limitations potentially there, but we can look at that, and in fact we'll talk about that later on. Do we use SATCOM? Do we use a blend of the two? So there's all of these kind of challenges. How do we get that regulated? There's no standards agreed across the uncrewed fleet yet. So if we're going to adopt a similar model to manned aviation, where we have the ICAO standards and then regulation, we need to get there on our journey as well. We also looked at the data sets, the type of information that we're going to have to be changing around, and also the infrastructure, again, to really exploit some of the use cases we're talking about. We can't rely on flying them from major airports and controlled airspace. That's just not going to work. We need to open up the infrastructure that supports the flexibility offered by the solution. And indeed, part of the project is to deliver papers on these topics, so they'll be available for people to look at. That was a bit of a whistle-stop tour. We could talk about regulations all day, but I'm not going to. I'm going to hand over to Joe, who's going to start getting into some of the more technical detail on what we built and how we tested it.
Thanks, Craig. I'm Joseph Lamb. I'm a Principal Solutions Architect from Thales, and similar to the theme here, I'm going to do a very quick whistle-stop tour of what the enterprise architecture we've done. I think it's always very important for people here to, and virtually as well, to understand some definitions first. I think it'd be quite helpful because it's quite a big subject matter. So what is an enterprise architecture? Essentially, let's break it into its two constituent words. So what is an enterprise? An enterprise is an organization or organizations that share common goals and information. And what is an architecture? There's a formal definition and a standard for it, and that is fundamental concepts or properties of an entity of interest in its environment embodied in its elements, relationships, and in the principles of its design and evolution. So all those words together, in summary, an enterprise architecture is a combination of strategy, business, and technology. A common misconception is that architecture is just about aesthetics. It isn't. What makes a good architecture, and a good example I like using is the concept diagram for Heathrow Terminal 2, is that's a good example of an architecture, but it isn't just about aesthetics. It has good structure. It has organization, cohesive functional and non-functional properties. It has people, process, and technology. And it's what we try to embody when I talk to you about the architecture, is trying to distill that good design and structure in there and how we represent it in a model. So what you've heard from Alberto about the use cases, you've heard from Phil about the market side of things, and you've heard from Craig about regulation, the different sort of layers in the overall airspace management and design. And by putting them together, you can see the complexity starts growing as you introduce our understanding of this. And it was very important as part of this project and as a team that we had a common way of communicating this and also managing those dependencies between the different interests and viewpoints that we bring as a consortium, and also as industry, and which bits are contributing or which place we could impact another. And we had to understand how to structure that. So by taking this approach, we represent the architecture in a model, and each layer that I'll talk about is how we built up the key structures. So the first one obviously is looking at the enterprise layer, which is about business models and the use cases. So how do we practically operate the management of the airspace as a business? It's as much as we like to manage things, have to operate as a business, and that's one of the key layers. The next one, which I'll talk about a bit more, is about the logical side of things. So what is the context of the airspace and the entities? What are the rules and regulations? What are the processes and activities and procedures? What are the airspace users and stakeholders? Ultimately, what are the key rules and processes and capabilities required to manage this sort of logical layer? And something more familiar to a lot of people in industries, also the solution layer, more the sort of technology type layer. So identify where the current technologies are, and analyse where the gaps are and propose sort of technology roadmaps. So a lot of the technologies could fulfill a lot of those logical layers, which is quite an important pattern that we try to distill from this. And ultimately, what's the actual solution combinations can achieve what we've described in that sort of logical layer. So what is happening today is very important, but the next important pillar we included was the time domain. As you appreciate, things move on, technologies move on, but they don't necessarily move on just for the sake of moving on. They have a reason because things improve or we have a better understanding. And we wanted to make sure that when we did this model, the architecture could incorporate that change of time. So we're looking at today's vision for tomorrow, which is 2030. I'm sure by the time we reach 2030, it'll be another a step forward, and it's very important to understand that. So this is an example of the various different layers. This is a very simple depiction. I haven't got time to go through all of it, so what I'm going to cover is a bit how we represented the use cases, how we managed sort of the interaction and processes, talk a little bit about how we represented the regulation in here, and a little bit around chorus. The first one is to describe sort of the sort of logical layer, and this is where we start off at. I'm talking a bit about what the context of setting the scene of what the use cases are. So in the model you'll see in a moment, I've prepared a short video to show you the logical use case video and show the sort of the layers that we have of different views. We've got one on the far right, which you can see is an example of the light goods sort of delivery use case, and the one at the bottom is more of like an inspection for agriculture. So just to give you a flavour of what those views look like, and I'm just going to talk you through a video describing that. So what you see here in the model is an example where we can select different types of use cases which have been populated. We're talking about light goods here, but there's a number of views that describe the various layers. And what we're going to go into is looking at the context layer here. So this very briefly describes what the use case is about. There's a lot of information, so we hid a lot of it to show the key information, but if we wanted to find more stuff that Alberto did, we imported a lot of those 129 use cases in there about them. We also have a link to the trials, which is being tested, and the bottom I'm selecting now is basically about how it associates with the appropriate chorus services. What you see here is the 129 imported into the model, and how we showed in red the key ones that show that sample set that we picked from each use case represents a common pattern across all of them. So rather than trying to do 129 tests, we smartly looked at what if we did a test from each sort of sector, we took a good representation to sort of verify and validate the way we approach this project to make sure it's representative of how drones were going to be used. That's just an example there of how we pick them. You can see there's light goods and heavy goods in that particular one. That's the sort of context layer. The next layer I'm going to talk about is about the interactions and the information exchanges. So to give you a bit of a heads up on how the diagram is viewed, you'll see this diagram appear in the model in a moment. And it's broken into 4 key boxes and a lot of circles and a lot of lines in between. So the circles essentially are nodes, and nodes aren't necessarily technology, but it's a logical depiction of organizations, people, process, and technology as a very high logical depiction. And the interactions between them at the highest level, what must sort of happen, and those are the information exchanges. But ultimately between the 4 boxes, so the outer box is what use case you're using, the far left is sort of the enabling services, things like air charts, so aeronautical information services, or geospatial information services. They're sort of like your charts and your maps that you typically get to sort of enable that space. And the core at the center is what this project focused on, those particular nodes, which by no surprise are the actual drones themselves, the service providers that operate those drones, and sort of the airspace management from the UTM perspective. And we've also included sort of piloted aviation traffic managers in there. So that's that. So I'm going to show you another short clip video of what's going on there. So as you can see here, the same diagram again, but what the model does do is when you select an individual line, what's associated with those interactions are generated by the model. And it tells you what high-level messages and directionality where they are. And that's just an example between a service provider and a drone, what sort of information. As you can see, what a drone provides to the service provider, etc., is different. And also, that's a graphical representation. We actually have a way to put it in a large table. As you can see here, there's quite a lot of information exchanged between those where they go from, and it can be exported out the model as well. So we've done quite an extensive analysis to make sure that works, and also we can select which ones we want to see, and that's what. So that's a very quick whistle-stop tour about the logical entities and sort of information exchanges. But the next one is about activities and processes. So we talked a little bit about the information exchanges, but what actually generates them? Those are actually activities conducted by those nodes to actually generate that information. It's important to understand what actually does that. And how we've depicted it is looking at the various flight phases of a typical day in the life of a drone mission. So starting from flight planning on the ground, all the way to taking off and doing some effective, useful activity, which is in the air, coming down to land, and then doing some sort of post-flight sort of debrief. And we've broken it down there, and how we've approached the process and how to articulate those interactions is we took a simple sunny day scenario, but what you see in the sort of in-flight bit is that we considered other scenarios, such as what happens if the drone runs out of power, what happens if there's an incident. Now, as a project on timescale, we couldn't do all of it, but we started with, let's start with everything is going well scenario and incorporate them sort of later. So we have started that journey, but we haven't completed them because we want to make sure that we've got the full end-to-end of a sunny day sorted out before we deal with incidents. And what you'll see in the video next is an example of how the model again shows you the dependencies and things. So in this one, it's agriculture. Again, you've got a set of activities that flow from one to another. We are going to go into the light goods delivery one. And as you can see, the model will generate what we've linked up. I'm going to show you the bit when you go into. I'm not going to go to every line and activity of showing how it's connected. We can talk about that offline. But ultimately what it's showing is that it shows all the logical information flow. And if you go into each one at the microscopic level, you can see what feeds that activity from a source, but also where it goes to. And more importantly, how it links back into associated with the Chorus services that were designing a big influence on our project when we were designing this. And just to show you another example from a UTM service provider, you can see there are more services that particular activity provides. And if we look at the sub-activities involved in that, it shows out which services are being conducted at that particular activity. So there is a level of fidelity when you start diving into this model of describing that process. And it's an important one that we're using for trials as well. It's something that's being tested. These are just examples of stepping through different phases. As you can see, there's quite a lot of information on there. And then let's go to Chorus. So how we translated the Chorus services into here. So what we tried to do is understand what Chorus started off with, how it related back to use cases, how does it relate to sort of requirements, so that's the left and right, and how does that flow into the trials and solutions and sort of the capabilities at the sort of top level. Now, in the actual documentation, if any of you have read Chorus, they come out with two tables that describe, here's what service is required for X, Y, and Z, and here's sort of the service required for maturity U1 to U4. Now, that's not particularly helpful if you have to try and cross-reference it. So in the model, what we did was, we made an n-squared matrix and combined that complexity so you're able to select and understand the differences between them. And actually, we discovered some interesting sort of results. So I'm just going to show you how we represented that in the model, and we're selecting the mandated ones for what Chorus describes, and you can see it looks at the different parts of the grid, so you can quickly assess which bits are there, and then how to compare the grid. We can do that. And interestingly enough, even whilst you're seeing the comparison there, we've also identified there were Chorus services that Chorus identified but actually didn't link. So we've already noticed there's some anomalies already with understanding that. But importantly, we're able to determine what are the key differences if we're working from one airspace type to another. And I think that video very clearly showed that the complexity goes up as you go to more sort of high risk and densely populated areas, by no surprise. So for us as a community, we need to understand that complexity and services that we are providing to manage that airspace safely. And then we talk a little bit about regulatory reviews. I know Craig's talked about it quite extensively. What we did represent in the model is the standards and documentation. So things, as you can see on that diagram, from the sort of the drone ops in the air, we considered the airspace management on the ground, but also categorized it on the overlapping side of things for certification, standards, and standards for technology. And on the right, we looked at the aeronautical information publication. So how do we describe the requirements for managing that? And typically in sort of the piloted world, that's done by an AIP. But we're proposing following a very similar structure, and it's one of our outcomes from that. But just to show you the table inside the the model, and this is just a selection of a couple of them. It's quite an extensive table. It's by no means exhaustive, but it just shows you the level of the things that are connected there, and it's not small. But an interesting part is what we've discovered, and it shows you this is the complexity, and this is just standards and documentation. We haven't even gone to designing that, is if we took the core nodes, as you saw in my node diagram in the middle, those are the connections that we found that are related to documentation. You can see that is very hard to manage if you had to just look at documentation. The mods on, by structuring it, we're able to see that from that simple depiction, that's hard. And if I just go in an example of the video, you can see when I do select them, you can actually work out, well, it may seem like a nest, but if you select individual one, we're able to work out which is actually related. And I think that's a telling tale, isn't it? We're in this industry and there's so much going on. How do we stand a chance to understand it? And by modeling it and understanding the architecture behind it, we're able to try and to pick that and work out sensibly where we can tackle the problem. So that's a very quick stop tour. And then finally, leading on to sort of the trials aspect, we try to represent that link from what I've just described to you in the various different levels into the solution and how we're actually demonstrating that. So what you're seeing here is the various different entities and how we're applying different people, systems, and their locations to actual trials. And that's just an example of how we're able to see that from. So it's a connected model, and it helps us understand those sort of dependencies between the various different layers. And I'm going to hand you over, speaking of trials, hand you over to my colleague Swachanda, who'll talk to you a little bit more about what we're currently doing on that.
Thank you, Joe, for that. Hello, everyone. I'm Swachanda Avasare, and I work for Thales as a systems engineer in digital aviation communications. I thought my name was long already, but my title is longer than that. I'm also leading the trials on this project. So why are we doing the trials? We are conducting trials to prove the airspace of the future concept will work as expected. We have already seen the architecture representation from Joe. Shortlisted 11 high-value use cases, and Alberto's analysis shows that drone technologies will be used predominantly for light goods delivery. And my favorite example to give here is, imagine your favorite gin and tonic is delivered using a drone at your doorstep. Safely and efficiently, that's very important. So leading on to the trials, we want to ensure that the architecture that is developed and the technologies that are deployed that also test the trial chorus services through these number of use cases. That leads us to the test hypothesis question, which is, does the architecture developed in this project capture and represent the required enabling services from Chorus, airspace management operational processes or procedures, coordinated airspace operational environments, these are segregated and unsegregated airspaces, enabling airspace management and technologies, and the regulatory framework considerations that enable beyond visual line of So the trials are envisaged in a way that we validate the enterprise architecture, we trial the chorus functionality that is deployed by the different solution elements. We will be validating the operational processes and procedures using the architecture for each test use case, provide communications infrastructure modeling and post-processing analysis, and provide recommendations to the regulator. The trials were carefully planned over 2 phases. Phase 1 was to basically set up the test environment. Airspace of the future is, as you've seen, is a system of different UTM service providers providing UTM solutions. And then single drone operations. So once the test environment was set up and integrated successfully, we conducted single drone operations to ensure that the architecture processes are firstly correct, and also identify any gaps that are present in the current architecture processes for each test use case. So that is light goods delivery, agricultural use case, etc. The test environment is set up in such a way that we have a synthetic environment where we have digital twin, and we also conducted some live flights here at Cranfield Airport and also at Twin Woods facility. Phase 2 looks at drone operations at scale. So now that we have tested successfully the single drone operations, we know what processes are being followed and whether they're followed correctly or not. We now are looking at increasing volumes of drone operations and how the UTM will manage that airspace, whether the UTMs are able to support a high volume of drone operations in a given airspace. After that, we will be looking at consolidations of the trials, results, and analysis. And then in terms of communications modeling and identifying the wireless via the modeling, the wireless infrastructure and any loss of signal strength, etc., if we are using cellular networks for identifying drone positions, for example. This is an example of the trials area. As I said earlier, that we have conducted some live flights here at Cranfield Airport. So we have a representation of ZA airspace in the center there. Milton Keynes on the bottom left and Bedford areas are used as an example for testing light goods delivery use cases. We also are looking at Y airspace and conducting power line inspections and inspections at a wind farm, but that is being done in a synthetic environment at the moment. What does the system of systems test environment look like? On the left-hand side in the box, we have live virtual construction. So this is our simulation environment. We have digital twin, which is a simulation tool. Move it. And then on the right-hand side, you can see at the Cranfield Airport, we have a digital drone that will be flown for a given use case. And we have Blue Bear drone ground control station and air traffic control providing procedural support whenever there is live flying being conducted. We have online services such as geospatial, so all the supplementary services that make up or are used as enabling services to form the flight plans, for example, which are submitted to the two UTMs. The drone position, the way the live virtual construction is integrated is we are able to display the drone positions from the live flights on the simulation visualization as well, and also on the situational awareness on the UTM. Next section is about demonstration of the simulation environment. This picture shows you the situational awareness screen that you see on a UTM. This is from Angel Guardian UTM. In the center, you see the pink circles basically depict an area over Cranfield Airport. On the left-hand side, you see Milton Keynes, and on the right, you see Bedford area. So this is the screen an air traffic controller will see air traffic, whoever is basically managing the traffic for drones. We have another view where you can see all the blue rectangles are basically, these are the flights that were submitted into the UTM for strategic deconfliction. These flights have been approved by the UTM system. And they are depicted using the blue rectangles, and they are in Milton Keynes area and on the top right, Bedford area. A video of a 3D visualization on the Thales Digital Twin simulation tool. You can see a number of drone flights are taking place simultaneously. And these could be, each drone flight is representing different use case, for example, light goods delivery or power line inspection, etc. This is another video of how it looks on the left-hand side. You can see light goods delivery in progress. This is again, these are videos you can see, the visualization you can see on the left, on the right-hand side, top is power line inspection, and bottom right is visualization of airport runway. An example of a recent trial. So this is a view of situational awareness for an air traffic controller. They will see these pack labels for different drone flights that are taking place concurrently. You can see Ghost 3, DFC2. So basically, this view gives you the visualization of all the flights that are, all the drone flights that are flying in a particular concurrently. We'll hand over to Ollie from Blue Bear to talk about live flying.
Thanks, Rhonda. Hi there, I'm Ollie Witt from Blue Bear Systems. So yeah, we did some of the live flying. For those who don't know, we are a research and development business. We generally try and bring ideas to life and get them in the air, allow people like yourselves to test out ideas and fly whatever you need to fly on our systems. So the live flying that we did for Airspace of the Future was done with our Cobra UAV, and this is a platform that we developed in 2017, and it's now become one of our kind of workhorse platforms. It's got about a 3-meter wingspan, max takeoff weight of 8.5 kilograms, and we can fly them in swarms, or for this project we just flew the single vehicle. The platform is bungee launched, so on the far left picture you see Carl, our flight ops manager. He's about to pull the quick release for the short rail, and then in the center picture you see that there's a kind of bungee with a string attached to the platform. So it allows for a really simple and reliable launching process. The platform can fly for around 3 hours, and I think typically the flights that we did for this project were about an hour and a half duration, just testing the process for launch and recovery, entering the airspace, exiting the airspace, and really testing the architecture that had been set up within the program.
On the right-hand side, as you can see, our MCCS, the big blue bus, as we like to call it. This provides us a really good platform for operating all the trials that we go to. We used it for all of the Airspace of the Future projects and allowed us to communicate with the air traffic controllers and the different people that we needed to allow the flight operation process to carry out. This is an ADS-B plot from one of the flights that we conducted. This one's at Cranfield. You see a bit of a search pattern, and I think we were trying to show a perimeter search. As I was saying, the main point of the live flying was really to exercise and test the architecture for conducting the flights, not really what was actually happening within the flights. But this use case is a really good use case for the Cobra platform, along with the linear infrastructure use case. So that's a good one. And then this was a flight, again, ADS-B plot, so you can see that this has come straight from adsbexchange.com, and our platforms do run ADS-B transponders, and if you keep an eye out on Twinwoods and Cranfield, you'll sometimes see our UAVs pop up on your mobile phones. So yeah, this was an agricultural survey type flight that we did. We flew lots of different orbits around a mock field, I guess, that you could say. Yeah, so this is actually, we have two mission systems for our UAVs. We have a very basic safety GCS, which the future aspiration is that we won't need it, and usually on flights you do never need it. And then we hand over to our mission system, which allows us to do much more complex trials. So this is actually a simulation, but a view of that mission system screen. So you can see we've got the operating area, and what we can test and what we are testing here is the path that the vehicle flies is decided upon on the vehicle, and not from a very mandrolic process, single operator, single UAV, trying to move away from that. So the path is generated on the UAV and sent down as displayed as this yellow line. So this allows us to see what that path will actually be for the search area that we're in this case simulating, but happens exactly the same way when we're flying as well. And we can put in wind, etc., into the simulation if we need to. So that was a flight at Twinwoods, and then very similar down here at Cranfield to the operating area. So I think we've conducted 3 flights to date over the period of about 3.5 hours of flight time, and we're continuing to carry out more flying when needed. So I'll introduce Sam from Cranfield University.
Hi everyone, I'm Samuel Ayo, and I'm a research fellow here at Cranfield University. And part of our work was to look at the trial analysis. So a major part of this project is to actually analyze each of these trials. And as you may be aware, we've conducted a lot of flights, and we hope to conduct almost hundreds of flights, virtual and physical, in the course of this project. And so to inform future projects and also future adoption of drones in the airspace, we've evaluated each of these flights, each of our developed processes, and some of the core services that we implemented. And to help us with this trial analysis, we've defined a number of measures. The first one is the veracity of the operational processes and procedures. We want to check how correct are the processes and the procedures that we have defined, and how well do they help us to meet our trial objectives. And secondly, we looked at the number of flights that were accepted or rejected. And to manage operation at scale, we had to submit a large number of flight requests, and then to manage and to evaluate the airspace management system, we need to look at how many of these flights were rejected. And so it's like a measure of the airspace efficiency. And thirdly, we looked at traffic proximity analysis to see how close the drones were to each other, which is also a measure of how safe are these operations, especially when you are doing them at scale and where there is no traffic, where there is no strategic deconfliction. And we also looked at these core services and the systems that we have implemented. And we want to check how, if there are any shortfalls, if there are any gaps in these systems, just to help us to inform future development and to see if there are gaps in the chorus concepts in actual implementation. So we're actually putting them out there to test them in real life. So it's no longer a concept, but it's actually reality. And that's what this project is all about, to test these concepts and to implement the relevant processes and procedures. Also, especially for the live flights, we looked at the piloted and drone integration. So how well does the drones integrate into conventional airspace and into the ATC ecosystem, the air traffic ecosystem that we have today. So in the course of the trials, huge amount of trial data were captured, and they are running to gigabytes of data there, sitting down for us to analyze, both immediately after the trials and also afterwards when we do a lot of post-analysis of the trials. And also, all these data were now analyzed to derive a lot of insights and also to derive the measures I've just described in terms of traffic proximity and the veracity of the processes. And so far, the trial analysis have shown that our trials have demonstrated the robustness of the developed procedures and processes. And also, we've seen that the services are quite robust to enable seamless integration of drone into the airspace. And obviously, more analysis are going to be done afterwards, after we finish all the trials. And also, one thing we discovered from analyzing these trials is that it's so important to have information being shared by all the stakeholders. So coordination of every stakeholder is very important to ensure successful integration of drones into the airspace. And finally, we could see how complex it will be to integrate drones into the systems. And thankfully, our system that we have developed and the procedures we've developed in this project were more than capable to handle all the complexity and to give us a lot of insights about how we can integrate drones into the airspace. And definitely, they've shown that integrating drone into the UK airspace is feasible. And that's it for me. And also, some of the data we captured are the operational plans, positional reports, and manual logs. And all these data are going to be analyzed to provide further insights. And so the next speaker is going to be Dr. Arun Jayaprakash from Startups. Thank you.
Thank you, Samuel. I am Arun Prakash. I am from Satellite Applications Catapult, and I am Satellite Communications Systems Engineer. So I'll be talking about the wireless infrastructure analysis which we have done, and also how it is utilized for the post-trial analysis based on a tool we have created. So we have discussed the different drone use cases, the various technical issues, the solutions, the regulatory aspects, and also the simulations and live demonstrations that aids the advancement and development of the electric and autonomous aerial vehicle technology in the UK airspace. So from a futuristic perspective and vision towards enabling the beyond visual line of sight operation of drones, or to operate the drones remotely, we require the control and connectivity over wireless networks. And there is always a need to transmit a large amount of application data, for example, high definition videos. So in regard to this, cellular and the non-terrestrial satellite networks are well suited and are considered in the future as a solution. And it will be authorized in the future. So, hence we have analyzed the wireless technologies and how it can be utilized for providing connectivity to UAVs. So we have also created a tool for the analysis based on this. And based on the 3GPP specifications on the standardization and also the recommendations by 3GPP are captured into this tool. So these recommendations are captured in the Excel-based tool for the communication modeling, and this is utilized for a post-trial analysis. So to look at the feasibility of how the cellular and satellite technologies are fit into the UAV ecosystem. So now we'll have a brief overview on the tool. So as we have discussed, the cellular and satellite networks have the obvious advantages like utilization of the existing infrastructure and the spectral resources for UAV connectivity. But always there are some practical limitations that has to be considered. And the main practical limitation when it comes to UAVs with cellular networks is the interference. So from a cellular perspective, the drones or the unmanned aerial vehicles are considered as another set of mobile phones which are flying at a particular height. So obviously we have a feeling that this analysis would be similar. And also since it's flying at a particular height, it's not obscured by buildings or shadowed by the terrestrial obstacles, unlike the ground users. So obviously we feel that there will be a direct line of sight path and we will have a good connection. But that's not always the case. The UAVs not only see the main base station, it will also be connected to the neighboring base stations. So it receives signal from the main base station at the same time, it receives signal from the neighboring base stations or cellular towers, which are regarded as interference. So that will reduce the signal to interference plus noise ratio, which is a main or critical quantity which decides the quality of service or which decides how well the UAV is connected to the base station. So that realistic parameter decides most of the factors like coverage, what would be the data rate performance, etc. So that is the first thing which is captured into the tool according to the 3GPP specifications. So the input to the tool will be the actual locations of the cellular towers of the particular area of interest where we intend to fly or where the trial is happening. So the latitude, longitude, and height information of the actual cellular towers at a particular region is provided as input to the tool, along with the system parameters like the transmit power and associated losses. The next input will be what is the position of the UAV, the latitude, longitude, and altitude of the UAV. Other realistic parameters which reflect each stage of the flight are also included. For example, when the UAV is in the takeoff stage, it will be obscured by buildings. So there will be different probabilities of line of sight and non-line of sight according to the height. That is one factor which is captured. Along with that, the path loss or the channel model will be varied. That is also captured. So based on these inputs, the tool analyzes or quantifies what would be the signal quality based on the calculation of signal to interference plus noise ratio, whether the connection status is a pass or fail, whether the UAV is connected, and what is the serving cell base station or which base station it is connected, what would be the data rate provided based on this. So this is the sample output, which is on the right hand bottom side is the sample output, which is provided by the tool for a particular UAV position. Now we will see how this tool can be utilized for a post-trial analysis. For example, if we provide the entire flight path data at each instant of time, where is the UAV, what is the longitude, latitude, and height, altitude of the UAV into the tool, along with the other system parameters, along with the location information of the cellular towers, and when we provide the time information as well. This tool will calculate these outputs at each instance, and then it will look at how well the UAV is connected. So as the UAV flies in a particular region, all the informations are transferred into the tool, and if there is a connection, it is shown as green in the output visualization. And where there is no connection, it is shown as a red. And also, the signal quality, which is indicated by the signal to interference plus noise ratio, is shown at the base with a particular color map. Hence, how it is utilized for post-trial analysis is that, as we have seen, if there are no base stations, there will be no connectivity. So that's reflected on the right side. There are less number of cellular towers. If there are more base stations, obviously we feel that there will be a good connectivity, but due to the interference, we will have, on the left side, we can see there are some red areas because of more number of base stations. So more number of base stations and less number of base stations are going to be a problem for UAVs. That's where we can utilize the satellites. So that's the insight which we get from the tool and how it can be utilized. And also, it can also be used for a flight path planning analysis, because before flying, if we have the location information of the cellular towers in a particular region, beforehand itself we will be able to know whether the ULV will be having connection throughout its flight and where we need satellite connectivity. So that's all from me. So I hand over to Phil Vernell from Thales. Thank you.
Thank you, Aaron. And indeed, thank you to all the presenters today. About an hour and a half ago, we had this statement, and I just wanted to perhaps check your memory, just to make sure you'd remembered it, but also just have a bit of a tick-off as to the things that I think we've achieved. Well, I'm sad to say that routine operational drone service in a safely coordinated environment on a regional national basis, well, we kind of never thought we'd get there at the end of an 18-month program. I still think it's possible within our 2030 timeframe, but you know, that was always going to be something we weren't going to achieve. But that was set out, and the subordinate statements underneath this were enablers to us to get there. And I think we've looked at the robust business cases. You've heard from Alberto and Phil with regards to the analysis that's been done on what drones are going to be used for, and understanding what those business models are going to, the beginnings of them anyway, maybe not the complete picture because we've done the flying side, we need to the environment, the ground environment side as well, and that is still work to be done. Through the briefing from Swachandra about the trials, you've been given an understanding of the synthetic environments and the work that's been done then. Not only the synthetic environment, but the live flying parts as well by the Blue Bear team, and the simulations and the analysis that's going to go on to give us an outcome from those elements of the program. And you've also heard from the stakeholder and public engagement. Craig gave you a briefing about that, the fact that we've engaged with the regulator very heavily, really important stakeholder. There have been end user stakeholder engagement. Alberto didn't actually mention that, but they've been out and they've been talking to people about what drones are going to do in the future and how they're going to be operated. And we begin to thinking about the integration into the transport model with aviation as its core, and the whole program has been about that. So I think I would give us probably 8 or 9 out of 10 at the moment as to what we'd intended to do and what we've actually achieved. There are a few gaps, I'm happy to admit that. It was a challenging program at the start. It still is a challenging program. We've still got a little time to run to the end of August to complete the program. But I think we're on track to do quite a lot. So I'm going to hand over to Andrew Chadwick from the CPC just to give us a few closing statements. Andrew.
Hello, my name is Andrew Chadwick. I'm with Connected Places Catapult, and it's great to speak to you today. Just really want to provide an overall summary of the achievements that we've had with this project. Interestingly, we all got together. It was about 3 years ago. We came to Cranfield University and we had a meeting. The 9 partners you see here. We wanted to do something. We weren't sure what exactly it was going to be, what the size and the shape of it was going to be, but we wanted to do something, and we had a title. It was Airspace of the Future. And I'm delighted just to see how far we've come in those 3 years. So much that we have actually achieved. We've come together and worked so closely, particularly in these challenging times over the last couple of years. I mean, the majority of the things you've seen today, apart from some of the live demonstrations, have been all online. And to be able to achieve that is quite amazing. So we have developed our own enterprise architecture for the airspace of the future. It's one of the first ever. We have validated use cases, hundreds of use cases. There's no excuse now for saying there's no use cases for the use of drones anywhere. We can demonstrate, and we have the business case analysis that supports those use cases. We have the airspace design and the approaches for future airspace management systems and those structures, and that's been proven and demonstrated by end-to-end synthetic environment through the demonstration, so we can actually have assessed and we've demonstrated those architectures, all those regulatory concepts and the procedures, and we have demonstrated with live flying. And currently, we're just completing the road mapping that will capture the way that we will take or would take forward the airspace of the future project. The project itself is finishing at the end of August, but we have achieved so much, and all of this is being taken forward into other projects. A number of the partners are moving on to Future Flight Challenge 3 projects, and some of this outputs will be taken there. Others are working together on other programs and the partnerships and new consortia, how they can develop new solutions. And some of the partners are developing products and solutions that they will take to market. There's an exploitation route for everything that we've done. And we've achieved so much over the last 3 years and worked really hard. And for me, it's been an actual privilege to work with you all as a team. So I thank you for everything you've done. And we're going to the questions and answers, but I just wanted to remind you on how much we have achieved. And the presentation, hopefully this morning, has just shown everybody else that's not been party to your great work, just what great work you have actually achieved. So from myself, I'd like to really thank you, and I think we're going to Q&A. Thank you.
Amazing. Thank you to all our speakers. It's a very high level, but a great representation of the incredible amount of work that's gone into this project and the very holistic approach we've taken towards how we build towards an airspace that integrates safely and sustainably the unpiloted aviation into the existing environment of piloted aviation. How's everyone feeling? That was a lot of information to share with everyone, but we've benefited from a lot of research work that has been previously conducted, and we are very keen that we share the work that we've done in this project so that we can continue to build on it and work with everyone in the industry to actually achieve our vision. Are there any questions? I'm going to ask very quickly just first for questions from the room, and then I will pick up the questions we've got online as well. There we go. Actually, can I first invite all the speakers to join us in the front, please? Make it easier. Oh, right. Is that working? Is that working? Excellent. So I'm going to hand you that mic to pass around. Yeah, not that you have to answer all of the questions, but just pass it around, please. Thank you.
Thank you. Kate Chandler from Synthesis. Fantastic presentation, really interesting, and great to see the work that's been done over the last couple of years. 2 questions, if I may, initially. Will the use cases be made available to the wider public and audience, SMEs and so forth, so they can adapt technologies that may already be existing? And what, if any, considerations been given to utilising existing technologies, for example, within tactical data link domain, multi-link test facility integration, which would give the wraparound to your project?
Thank you so much for the question. So yeah, I think the intention is to be as open as we can. Of course, being wary that there's some things that is expertise from the partner, so we need to check all that. But yeah, I would say maybe it was more like a project management question but I personally would be keen on like engaging, like, you know, if like later to share like what we found out, because we rely, like we did an exploration of the, you know, what was already there, so we didn't want to repeat, just build on top of it. And I think we added like really value, like putting all together and then giving that extra classification to give more information, so it's not just like, you know, use cases here and there. So yeah, and the second question, I don't know who is the best person.
Probably second part of the question.
Could you repeat the second question, please? Sorry, I didn't quite catch it.
Thank you, Phil. My question is, what consideration has been given to utilising existing technologies, for example, development through the tactical data link environment, and using integration and standards validation tools that are already there that could be utilised as a wraparound to enhance your project?
Yeah, there are a lot of existing technologies. Primarily, I think there's radar systems, there's communication systems in terms of mobile phone networks, and a lot of these need to be part of the solution. But part of the problem with these is that obviously they've got to meet the regulatory requirements. Currently, I think there's an issue that if you wanted to, for example, use the mobile phone network to put command and control signals to platforms, the regulator would probably have a fit, because it isn't developed to that safety level. So we want to use the existing technologies as part of the solution, because we've got to. You can't develop a completely independent infrastructure to support drone operations. It's not going to work. It just doesn't make economic sense. So we've got to use the best that we can, but we've got to use it within the regulatory bounds. Obviously, a lot of the technologies like the radar systems in airports, etc., would be used, but obviously they're pools of capability rather than something which covers the whole country as a universal solution. But the answer is yes, wherever possible.
Hello. So my question was more towards the satellite applications. It was a very, very good presentation and simulation of when it fails and when you have the connection. So two things really. Of course, as you mentioned, more base stations doesn't necessarily mean more connectivity, you know, because of all the interruptions that's taking place. So were you able to come with some sort of a solution to block out certain base stations when you're getting a good signal from a different one, and probably try and reconnect if you're losing out signal on that particular station? Was that something that was considered? And the other one was, when it failed, were you able to kind of simulate the latency or the distortion between the signal that's coming from the satellite and the base station itself? Of course, there's going to be some sort of a latency gap when you're shifting between one and the other. So how does that affect in terms of your operations?
Thank you for the question. Actually, the first part of the question, I shall answer that first. So when we have interference from neighboring base stations, how to cope with that? So there are reference signals that can identify whether it's an interference or it's a signal. That's one of the things. And using directive antennas are a solution, because obviously the base stations currently are optimized to serve ground-based users. So they will have a downward tilt towards the ground-based users, and the UAVs are served by the side lobes rather than the main lobes. But if we have more directive antennas with the coming of massive MIMO or MIMO technology, we'll have directive antennas, and we can direct beam specifically towards the intended user, which is the UAV, and which will not be receiving any interference from neighboring base stations. There are many solutions which can be done. This is the basic existing technology, and in future it will be happening. And regarding the latency, yes, I have showed a picture of, I didn't explain that, but it's a practical implementation of integrated satellite and terrestrial connected UAVs. So basically the UAV will have a satellite modem and a cellular modem, and an intelligent router which will intelligently switch between the satellite and cellular connectivity. Obviously, the latency issues will be there. We have simulated just the cellular part. We have not looked at the satellite part, because the latency issue will be there, but the coverage can be provided. So with the coming of LEO satellites, still we can bring down the latency. Thank you.
Thank you. I'm Steve Clark from Cambridge Sensoris. We manufacture radar systems for use on the ground and also in the air. Joseph from Thales, you talked a lot about the system architecture, which was really interesting, and you hinted at the technology roadmap, but then said very little about it. Perhaps you could tell us a little bit about the technology roadmap, possibly as relates to sensing, which is the area I'm interested in, and how much of that can you reveal, and how much is proprietary?
So I can definitely show you after the chat a bit more of the model if you want to see that. In terms of the timing of things to show everything, it's quite hard to show the entire model, but what we have got in terms of technology is what we understand today in the infrastructure. Now, as one of the audience here has already mentioned about connectivity and cellular side of things. Now, we have to understand that the conspicuity aspect of what connects to the drone, either directly as a point of communications or a means of sensing to actually detect where they are, is very integral to part of the number of services that we'll have to consider to manage that airspace. So you're rightly saying, you know, in terms of like radar surveillance type, you know, there's primary, secondary, there's a number of ways to detect where a drone is, but also where a drone can actually report its position to identify itself. And things like ADSB is another example of how it can track that. So we are capturing what exists in the current technology, but also consider how they fit into sort of the core services that sort of define how the airspace would like to be managed. So we do have bits like that in the model today. In terms of what you've heard from some of our of the team today, have mentioned about bits of what we're trying to test and pushing boundaries. People want to use, like, you know, cellular, they want to use satellite, other means. So we are considering, well, if we were to use that, they're not currently regulated and standardized in a way for use for drones because they point in a very different direction. So we have considered them. I haven't shown you much today, but I'm more than happy to show you after this talk if you want to see some bits.
Thank you.
Hi, my name is Jibril Kawa from Connected Place Catapult. Thank you very much for this very interesting presentation. I've got a couple of questions. My first question is around the connectivity. As you all know, automation depends heavily on connectivity. The connectivity analysis I saw have a lot of issues in takeoff. How do you mitigate that problem? And the second question is around the data. So what kind of data did you collect during the use cases? And what kind of tool did you use to analyze the data?
Okay, so thank you for the question. So to answer the first part of the question, so while takeoff, the UAVs behave similar to that of ground-based mobile phones. So the issues mainly are caused by multi-path effect due to shadowing, due to the obstacles, as well as due to the Doppler shift. So all the solutions that are recommended for the ground-based mobile users, a fast-moving mobile user in a train, similar kind of solutions can be applied to UAVs during the time of takeoff because they are obscured by buildings. The channel behaves similar to a wireless multipath channel with Doppler, a time-varying channel. So all those channel equalization techniques can be applied to solve that. And can you please repeat the second part of the question?
The second part is around the data collected during the use case. So how did you analyze the data? What kind of tool did you use?
Yeah. Thank you so much for the question. So to collate all the data in a simple fashion, we use a spreadsheet model because at some points it was more qualitative. So it was just useful to put the links to different sources, put whatever numbers we found. We use an online platform to do the workshops, Miro board. And we use that to as well get more information from partners, observations, and then we fed them back into this spreadsheet. And we created kind of like a connection, like a template, so it's easy to import into the architectural model. So that was a lot of work with Joe to make sure that that's automated, so he can do like reports. So we just had to be aware of some like the format on which we store the data. And that was a separate software that he used in the architectural model, and that's more complex, more advanced. But yeah, we've been using mainly the spreadsheet to visualize and put everything together. Thank you.
Hi, Adrian Clark from NUTS. Did the project look at separation, either drone versus drone or drone versus anything else?
In terms of the trials, yes. There are two levels to that. And also in the explanation of the different types of flying, without going into too much in the complexity, the way that the Chorus system suggests that you manage airspace is different in the uncontrolled type X to the Y and Z airspace. So the way we set it up was in the Y and Z airspace, flights had to be pre-planned. X, the system says you don't need to do that. Whether that's true in practice or not, we're trying to determine. And as you quite rightly say, one of the parameters that we need to look at is if you manage operations at scale in that way, how close do drones get to each other? Which is why it's important that the work we're doing starts and is looking at drone operations at scale to take us to the maximum expected volumes of operations pertinent for the particular volume of airspace that we're looking at. So if there was, say, 75 flights that you expect to have in that type of airspace, first thing you do is say, okay, of those, how many would be deconflicted strategically? That obviously reduces that number significantly, but some of that number will be flying in type X airspace where there is no need to put in an initial flight plan. So one of the things we're looking at, and actually, as Sam would have mentioned it, was that we're looking at the separation. So when drones are flying all over the place, we would hope that the ones that have been deconflicted strategically don't get anywhere near each other, but there's all these ones that are flying around in the X airspace. So trying to understand whether there is an issue or whether it's not an issue at all is one of the things that we're doing. So the answer to your question is yes.
Thank you.
Anybody else in the room? No? Do you want to move to someone like?
Yeah, I'll pick up some of the questions. So there's one around publishing flight trial analysis outcomes. So obviously we are looking at publishing some documents around safety and regulation, but there's a question about if we will be sharing flight trial analysis outcomes.
Yeah, so definitely internally, we'll be sharing a lot of that data with our stakeholders. And definitely, if there are opportunities for us to share it publicly, we will share it.
Yeah, so I think the flight, so the trials are currently ongoing, and the analysis work, it will be a lot of large amounts of data that needs to be analysed. So I think just to add to what Samuel was saying, we will see, some high-level outcomes that is obviously relevant for everybody else to sort of read, and we will include them in the outcomes, but we won't be publishing all of the trial analysis work. As you can appreciate, there's going to be a lot of data in there to share. And then there's one more question around the regulator's current position on drone operations, which I think Craig may be able to address.
Yeah, that's a bit of a big question, isn't it?
It is.
I think where we are at the moment is very much on a case-by-case basis. So when we're looking to push the boundaries and move forward with these BVLOS examples, it's done on an operational safety case being reviewed and then granted. So I think hopefully that I alluded to when we were discussing it earlier is we'd like to get to a position where we have ICAO standards, equivalency, and then we then have local regulations supporting those standards to make sure we meet them. Clearly, we're not there yet. I think that absolutely needs to be our objective, but I suspect that moving from the known regulations we are at the moment into the unknown will be through a series of steps where we submit a safety case, we demonstrate that that works, and then we take another step and we move forward. I would say that we're very much in the position at the moment where we're at those first steps, where we're proving individual capabilities, and then we'll move hopefully towards that standardisation.
Yeah. There's one around automation. So we talked about automation and autonomous drones. There's a question around what level of automation do we expect for these systems? And I know that's quite a vague question, so there's no timeline. So does anybody want to take that?
I'll start, and then I'm sure that we've got lots of people that can jump in. But I think when I think the vision that we took for automated is not having to have a single person coordinating a single vehicle or multiple vehicles. It's the fact that you can trust, and we've got the technology now, so this is something that we're doing where, you know, we're able to have a ground station controlling multiple vehicles. I mean, you know, the Jubilee was a classic example, you know, and we all thought that that can work. And that's a key step in opening up the capabilities. There's so many use cases that rely on being able to just let the system manage the aircraft. And I would argue that actually, from a safety point of view, that gives us a lot of pluses. You know, if you can prove that a system can manage the drone, and you can also demonstrate that in emergency scenarios it does the right thing, then that's safer. I mean, we're now getting to the point where we're talking about automating cars on our streets, and everyone's making a very strong case to say, well, actually, it'd be better for everyone if we automated cars. We're so used to jumping in. You know, in generations' time, they'd say, like, what, you actually had to drive the car yourself? You know, how dangerous is that? You know, so I think automation, I think we get very nervous about automation, particularly when we talk about regulation. We get very nervous when we talk about autonomous because you're then handing that control away, and you're asking systems to talk to other systems and make the correct decision. However, you know, to me, it's very interesting that in other environments we're talking about doing that because why wouldn't you? It's a no-brainer. But it makes us very nervous with drones at the moment. And the whole idea, we have this futuristic view of, you know, how many sci-fi films have you seen where you have all these drones and everything shooting all over the place, or they're all in perfect rows in the sky. You know, Star Wars comes to mind. But actually, you know, we're not talking, I think we need to get away from this vision that that's looking way into the future. It isn't. You know, with the technology, hopefully we've demonstrated, we're making really good strides on that at the moment. And there's a really good argument to say it's safer all round if we do it this way. But what we need to do is demonstrate how we go from the known environment now to that automated, autonomous, in a way that the regulator is comfortable with. And I think, for me, that's one of the major challenges going forward. Does anybody got anything to add?
I think the major challenge will be where piloted aviation and the autonomous or drone aviation meets. In that there's got to be an interface there where the autonomous systems talk, in inverted commas, to the piloted aviation and the piloted aviation management systems. And that's probably going to be the challenge. I mean, as Craig said, if you took the man of everything, it'd all be wonderful. It's when you've got man in the loop that usually causes the problem. But so we've got to manage that interface, and I think that's one of the keys to be put into place in order to deliver full autonomy.
I'm just going to...
Thank you. On the basis of that answer to the whole panel, one question I have is, do you think that possibly due to the financial backing, the hedge fund investments, etc., and the aspiration to move drone technologies forward, that there is a risk to the safety and regulation not being met with standards not yet being developed? Do you think you're running before you fully realised how to stand up?
There is all risk. There's always a risk of that. But if I could say that the regulator is risk averse, I think that would be a reasonable statement to make. And obviously, you know, when it comes down to it, none of us want these things to go wrong. So I don't think that we will run before we can walk. But I think your point is well made, and we need to make sure that we do keep within the bounds. And although we are pushing the regulator to make decisions and to come up with a set of regulations that we need to follow, we understand that it's a very complex environment. And therefore, we've got to give the regulator time to get their act together in order to give us a set of boundaries within which to operate.
I'd also suggest that we actually are going backwards with autonomy. We have flown autonomous drones, aircraft, for a number of years. We are now waiting for catch-up from the regulator, and that's really what's holding up the industry itself. In fact, I know of a number of companies who actually stopped developing autonomous systems because they cannot get approvals to fly, and that's the only reason we're not doing it. So the technology is there. It's just a regulator who refuses to engage with the industry and understand what this technology brings. So I'm going to put that one out there. I'm not going to be as I'm not going to be as polite. I think we're being held back, and we are being held back.
And can I add that, of course, we need to do projects like these. Obviously, we're testing things because it is about identifying issues early and resolving them, so that when the regulation is in place, at that point we can't be then starting this work. We need to be ready to go. So that's why I think there's that chicken and egg. But also sometimes the demand's already there, and the industry needs to kind of respond to that, and we can't just wait for everything to be at full capacity. So we sort of have to take the lead. Some areas have to take the lead. So actually, I'm going to combine a few questions and sort of talk to the panel about public perception, because that's quite a related thing as well, because we talked about safety and public perception of drones. Are there any thoughts? It's not something we've looked into in detail, but we have engaged a lot with stakeholders. So did anybody want to comment about how we are going to work towards public acceptance of what we think is inevitable, which is using drones for multiple use cases?
I have the mic. I will start.
Andrew?
I don't think it's about public acceptance. I think it's about public engagement, and we're already doing that. So within Connected Places Catapult, we manage on behalf of government the Drones Pathfinder Catalyst program. And within that piece of work, which we've been doing now for about 5 years, last year we actually performed a public engagement piece, and that was to talk to the to talk to the public about the use of drones, to get really feedback on really where the status was on their thinking, their understanding, and also their, whether they actually get it, and I suppose acceptance. And we were really delighted because we had a really positive response, and there was a number of cases. In fact, we've demonstrated them today, or shown them on the screens today, and we've been doing it as part of the Airspace of the Future program. So it's around those services, around the blue light services. There's also some, and we didn't go into too much detail, but around about the medical deliveries and those others. And the public and the other stakeholders we've spoken to see the benefit of those, and they're quite acceptable of those. And in fact, I think particularly with the examples, not just from this project, but also things that have been in the press for the last year or two while we've been going through the COVID, has shown now that there's actually an expectation from the public that they will see more of these systems. So it's for us as an industry to actually meet that expectation, and we should be flying more and more and showing the positive benefits of using these systems themselves. So the engagement is ongoing. One of the outputs we had, so those who are in the industry itself, there's a document on our website which actually talks to you about, or explains to you how to engage with the public, particularly if you're going to do services around towns and cities, so how you go about that. And I think it's important that we continue that conversation and bring the public along, because they get it. They get it really easy, actually. Once they see the technology and they see the benefits that drones can bring to their everyday lives, they get that, and they're accepting of that. And there is now that expectation. So it is very important. It's something that as an industry we're probably more aware of than other parts of this industry itself, or other sectors within the industry. And yes, definitely something that we're taking forward.
I'd just add to that in this program there's been some analysis done at a high level, additionally to what Andrew has said. But also, Cranfield here is a Centre of Excellence for Drone Operations, and they do fly a lot of drones out of the airport here. And I know for a fact that the airport has carried out surveys right down at the grassroots level, putting out surveys to people in the local environment, whether they be farmers, landowners, villagers, etc., in this area, and gained feedback. So I know it's been done right from that bottom level up to the high levels. So yes, it has been something that's been considered, and a lot of work has been done there.
Just to add as well, just from a future flight perspective, it's not just with this project. A large number of the programs in phase 2 and going forward into phase 3 do have that public engagement piece as part of their program itself as well.
Yeah, just to add on that, I think there's also lessons that we can learn from other areas as well, like micromobility. So through the Catapult, we've engaged with a number of sort of these shared e-scooter providers as well. And you know, when those sort of vehicles end up on the streets, there was some negative perceptions from the public, but actually through engagement with the public, through engagement with different community groups who may have different concerns about those vehicles, they've managed to alleviate a lot of those concerns and build public acceptance. I think from our side, you know, we can take lessons from that in how we want to approach engagement with the public to build acceptance of drones.
Yes, I'd agree. Engagement is really the key word. When we do our drone operations, we have to go around and speak to people, and the only ever time we have trouble is when people don't know what's happening, don't know what's on the systems. They assume that every drone has a camera and is going to look in their window, that kind of thing. So the more that the public learn, you know, we mentioned the Jubilee light shows, the drone show, things like this. The public perception and the engagement, as soon as you engage and people realise that actually these things are doing good, their perception changes massively.
I've got one more. It's about someone's asking if the ambition is for UK PLC to lead the world by 2030. Could you comment about your progress made against competitors elsewhere in the world? Do we think we're going to be leading in 2030? That would be my first question.
Okay, I can only talk about the projects and programs that I do know something about. The States, perhaps not surprisingly, have thrown lots of money at this problem, and they're looking at a different concept as to how drones would operate. They have a different regulator. Their regulator has a different view of this. And so they're moving ahead with their regulator and within their regulator's operational and requirement boundaries. Thales, a French company, so I can say that the French have already rolled out capabilities into a number of airports, as have we in the UK. UK PLC, not Thales. But are we ahead of the rest of the world? I would say we're on par. I think there's an awful lot of research that's done here that isn't done elsewhere. We're certainly not behind, I think, is the answer to your question.
Yeah, I think I would just reiterate that. I think, you know, we've got companies that are in this consortium that are already delivering internationally. I think we've got research facilities here and access to academia that is pushing absolutely the boundaries going forward, and I can't think of somewhere else that is outstripping us at the moment. I've certainly not seen it. I think it's fair to say that we are pushing, and I really like initiatives like I think Innovate. This gives us a really great opportunity to bring these, because otherwise we'd really struggle to get these kind of collaborations together. You know, we've got the catapults, we've got industry, academia, all coming together. I mean, that's a fantastic mix. And I really think some of the stuff that we shared today and some of the other projects that are out there are absolutely on that cutting edge. So I think we're absolutely fighting above our weight and pushing this out there. I think we've shown that there are challenges with it within the UK, you know, and those are to be overcome. But I think from a technology and just from a cerebral point of view and actually looking at what's the art of the possible, you know, things like the 2030 vision, that is absolutely on the forefront as far as I'm concerned.
I think the rest of us concur. Because, you know, we have done a lot of work like that use case analysis, the systems enterprise, which is actually bringing a lot of information that's done previously together. We're actually trialing how systems interact. So, yeah, definitely at par, if not ahead. I also have a very specific question, so I'm going to read that out. As a GA pilot leading the British Microlight Aircraft Association Airspace team, I don't see any progress towards true integration of IAVs with manned aviation in non-segregated airspace. How do the participants foresee regulatory certification towards this? For example, what frequency do you advocate for transponders for GA and UAVs?
I'll start, because I think I touched on it in my part of the presentation. It's a really good question, and it's key, really, in my mind. We made a point of saying that integration, not segregation, is how we need to do it. And I would also agree that we've not been able to demonstrate that as a capability yet. And I think as a nation, rather than just with the project, we hinted at the need to prove operational safety cases to show, first of all, you've got to get to a BVLOS state, right? So you've got to be able to fly your drone. I see that at the moment is being done in a segregated area. We know we're looking at things like transponder mandatory zones, for example. We're talking about mandatory conspicuity, and I know that that presents challenges for a lot of the manned aviation world as well when you're looking at parachuting and all these kind of things. I think we absolutely need to get there, and I think for me, if I can go back to one of the previous points I made, it's about this layered system. We can't rely on a single system to do it because it's not robust. And we'd quite rightly be challenged on it by the regulator. So I think there is a place for onboard sensors. There's also one for off-board sensors. There's absolutely a case for radar, because, again, that's a known aviation capability, so that you can tell the story for how that would come across. And for me, I see the unsegregated airspace as this variety of sensors and capabilities deployed, so you've got this overlay of different, and it gives you the situational awareness that you need to give confidence so that you can operate your microlight in the sky with a confidence that you are going to be made aware of what else is out there, and that it can also see you, and then we can deconflict them safely. Does anybody else want to add?
So there's a question about, will the MBSE models be made available for review? The interconnectivity of several systems allows a greater understanding and relative analysis amongst the different parties for safe systems.
The synthetic model, in its full sense, won't be made available now.
Yeah, I don't think we can, because there's multiple systems involved as well. I don't think we'll be able to provide that, would be the answer, I think. So yeah, I think we're learning quite a lot from the interconnectivity, so hopefully we will be publishing our findings, and that should help others, but we won't be able to share the models, unfortunately.
No, we won't be able to share the synthetic environment model, and we won't be able to share the architecture model in its entirety.
There's one more question. So there's a couple of questions that I think we'll just answer. They're about, documents being available, so we can just sort of provide links. But there's another question, which I'm going to address to multiple people on the panel. It's about who do you think the legal responsibility for drone safety and its operation resides with? Is it UTM or drone operators? So I think I'd love to hear from Craig, sort of just for Altitude Angel UTM perspective, but also Blue Bear and Thales as operators, just to see what your opinions are.
Yeah, that's a really interesting question. I can see why you would ask it. I would relate that to manned aviation in my answer, and say that in manned aviation, it is the responsibility of the captain of the aircraft to maintain separation and the safety of the aircraft. However, if I continue that analogy, they're also supported by air traffic control. So you're taking directions from another agency, so there's a responsibility there as well that you need to work in. But ultimately, the safety of the aircraft lands with the captain. So I would support a similar model, albeit I think it's a valid question. You need to look at the responsibilities because the whole uncrewed thing and being separate from the aircraft, you're relying on other activities, and that's absolutely something we need to look at. But I think, for me, I would draw as many parallels as possible between what we're doing on the manned side. I think there is a split of responsibilities. Ultimately, where the responsibility lies, I think that's a really difficult question. I would see, at the moment, I think the way we're being asked to operate, we're operating within operational safety cases, so I think that makes it very clear. If it's your operational safety case, it's your responsibility, and that's it. However, where the waters get muddied a little bit is when you're basing your operational safety case on somebody else's capabilities. And I think that's the journey that we need to go through. That would be my view from a UTM point of view.
Yeah, okay. Difficult one, I guess. I could see a scenario where we're operating under very broad operational safety cases, let's say. So one of these use cases, for example, may have a very broad operational case which would allow you to operate in a very broad way. And I would say as long as you're working within that containment, that perimeter of what you're allowed to work within, and as long as the system that you're working with does what it says it can do, I would say that you've fulfilled your kind of legal obligation. If that broad safety case has been granted to you in a manner that, or you know, in a poor way, which causes an accident, then unfortunately, I would have to say, I'd have to kind of put that on the person that granted you that operational certificate. So I would hope that we can continue in a way that we are in now, as Craig said, to have these lines of this is what you can do and have you done it. Otherwise, I can see, the question becomes a very difficult one to answer, and I hope we don't get to that point in court. Yeah.
Phil, did you want to add sort of Thales's view as well as the other operators working on the project?
Craig gave the textbook answer. I'd agree with what he said. We need to make it easier to get past the regulator. We need to keep as close to manned aviation as we can, because why reinvent the wheel? But the operator will be responsible up until we get to a point where the artificial intelligence and the autonomy is such that you can't divorce either ends of the management system and the operator system. Then we'll have to perhaps think again. But hopefully by that stage everything will be so perfect there never are any accidents.
Great. I think we have time for just one more question. So I think this is a good one to conclude on, because it's asking about next steps for the enterprise architecture. So I'm looking at Joe. So just sort of where do you see this going within the project, outside the project, in general, in terms of next steps for the enterprise architecture that you showed?
Very good and very tough question. So we haven't quite finished yet on the project, so there's a lot of wrap-up and publication that we'll have to do, and then we'd like to share with the community certain sets of those views, because I think it's valuable as a community that we're all pulling together in sort of the right directions. I mean, we've identified sort of the issues and challenges we face on this project, so I think that's a valuable lesson that we'd want to do. So that will, we're looking at sort of that's the short time scale. The longer time scale, that's a really good question. Not really gone to beyond this project at the moment, because we're trying to conclude our findings. So I know it's not a very helpful answer saying I don't know where the longer term aspect is.
It's the truth, that's fine.
It's one of those. I'd look, if, as I said, people online, people here, if there is as a community, if you think that is something that is a really good way of bringing us together to present a compelling case to work with the community and the regulators, speak up. I think that's the best thing to do. We're all in it together. We're all sharing the airspace. We're all users and contributors in some way, shape or form. I think the most important thing is actually speak out and talk to us, tell us about it. I think that's the way we're going to move things forward in industry.
think in an ideal world, we publish everything, the regulator would look at it all, we'd all get together and agree it and accept it, noting there may need to be changes, I accept that. Accept it and then move it forward as a single model for the future. But we don't live in an ideal world, so its future is a little bit muddy, I think, right now. But as Joe says, you know, that which we can publish, we will publish. And again, as he says, if anybody's got comments on it, then we'd be really pleased to receive them. We can't publish it for various reasons. We can't publish it in its entirety. We have been talking to the regulator about it. We've got an ongoing engagement with the regulator. The more regulator buy-in we can get with what we've produced, you know, then potentially the regulator then absorbs that and it'll come out and be reflected in the regulation that's issued. So it may be that it doesn't perhaps get issued through this program, but it's accepted by the regulator, and the regulator then kind of feeds it back out into the community. So it kind of, through osmosis, gets that may be a way forward.
There is a comment, sort of suggestion to say, have we looked at standards for CNPC, which is controlled and non-payload communications and spectrum specifically assigned by ITU for aviation and US CNPC? Is that something we've looked at? I don't think we have.
I think we've kind of taken the assumption that the detect and avoid challenge will be solved for this program. So there's the CNBC, all those kind of technologies, we've sort of just put them in a box and said, we assume that's solved. Because I think, as Andrew said, or somebody certainly said, there's a whole load of studies that are looking at that detect and avoid in its own right as a single research topic, and it is a very complex one.
Yes.
And right now, anybody that tells you they've got a solution look very hard.
I think that slide that Joe showed of the multiple documents that you have to look at to address that was quite a useful visualization of how complex it is. And yeah, thank you to everyone for making recommendations. I mean, we will obviously look at all this because there is a lot of research, and anything that anyone else is working on, we're very keen to hear. And we will share as much as we can from this program. With that, I would like to thank everyone for joining us. I wanted to let you know, obviously this consortium's got fantastic partners and a lot of expertise. For those who are online as well, they have virtual booths, so you can contact the organizations if there were any further networking or discussions that you wanted to have with them. So we should continue to have this communication in this community so we can all work towards our shared vision for an airspace that is safe and accessible to all. If you join me to thank all our speakers for today, then we'll close off and there'll be lunch and networking for those in person till 2:30. Okay, thank you. Fantastic. Thanks, everyone.
Thank you.